of different logic gates. It consists of AND gate, OR gate, NOT gate. Then there is a NAND gate, NOR gate. Then XOR gate, XNOR gate. Apart from this, we also have another gate which is called as a buffer. So this first three gates are called as the basic gates. They are called as the basic gates. One second. They are called as the basic gate. One second. Next, this NAND gate and NOR gate, they are called as the universal gate. So AND gate, OR gate, NOR gate are the basic gates. Okay, they are the simplest gate. That's why they are called as basic gates. NAND, NOR are called as universal because using this two, universal means what? With the help of this, we can construct all other different kind of gates. That's why it is called as a universal gate. So we'll learn one by one what are the different gates. So as their name suggests, and or not, NAND, NOR. So everything they perform the logical operation. So AND means they will perform the logical AND operation. So what will happen then? Now suppose we have two inputs X and Y, X and Y. Okay. Then output of this AND gate will be X dot Y. So again, this is not a multiplication. X dot Y doesn't mean it is a multiplication. They are performing the logical AND operation. So what do you mean by logical AND? So if both the inputs will be 1, then only your output will be 1. Otherwise, your output will be 0. So if we have two inputs X and Y, what will happen? How many input combinations will be possible? How many input combinations will be possible with the help of that? कितना combination possible होगा?
Four.
4. They are 0 0, 0 1, 1 0, 1 1. So this output will represent with X dot Y. Okay. Now this output will be 1 only when both the inputs are 1. So only for this last case. In other cases, one input is 0, so output will be 0. Okay. Similarly, now suppose we have a 3 input NAND gate. So in that case, we'll have 3 inputs X, Y, Z. So output will be what? This will be X dot Y dot Z. So what will happen? If we have 3 input, how many possible combinations will be there? How many possible? How many?
Six.
8 possible combinations will be there because 3 input 2 to the power 3. 8 possible combinations are there. So triple zero, double zero one, 010, 011, 100, 101, 110, triple one. So can you tell about its output? What will happen? What will happen to output? First combination, what will be the output?
Zero.
0. Next.
Zero.
So all the case it will be 0 except the last one because in the last case only in each input is 1. So for this combination only output will be 1. So this is called as logical AND operation. If all of the inputs are true, then only output will be true. Otherwise your output will be false. Similarly, it can be extended to 4 input also, 5 input also. Okay. So this kind of table, basically in these tables, what is happening? We are writing all possible input combination and its corresponding output. So this kind of tables are called as truth table. So truth table represents all possible input combination and its corresponding output. So the symbol of this is denoted with this one. AND gate symbol is this. So this signifies this is a AND gate. So this is a 2 input AND gate. This will be a 3 input AND gate. Similarly, suppose 4 input, this will be a 4 input AND gate. Okay. Next. Next is OR gate. So OR gate symbol is this. So this OR gate performs logical OR operation. Logical OR operation. So as per this gate, what happens? If any of the one input is 1, then your output will be 1. If any of the one input is 1, then your output will be 1. If all the inputs are 0, then only your output will be 0. So let us see what will happen. Now suppose we have two input x and y. So output for this OR operation will denote at plus. Again point remember, it is not a addition. This is a logical addition. This is not normal addition. This is a logical addition. So we will not have two outputs like sum and carry. Logical operation, so only two outputs are possible. Either my output can be 0 or output can be 1. So it is printed as x plus y. So what will happen? First combination, both of them is 0, so output will be 0. Next case, one input is 1, so output will be 1. Next, this input is 1, so output will be 1. Next, both the inputs are 1, so output will be 1. Similarly, tell for this 3 input OR gate, what will happen? Output will be x plus y plus z. So what will happen to this output? First combination, what will be the output?
Zero.
0.
Sir, zero.
What about others?
1.
Sir, one.
All others will be 1 because any of the one input is 1. Here this is 1, this is 1, this two are 1, this 1, this two 1, this two 1. Here all three are 1. So only for first combination output will be 0, other combinations output will be 1. Next basic gate is called as NOT gate. So what happens in NOT gate? NOT gate is basically nothing but a inverter. So it is used to perform the complement operation. So what happens? This is the symbol of this NOT gate. So if input is x, output will be x bar. Output will be x bar. So it has only one input. So if it is having only one input, how many possible combinations will be there? If it is only having one input, how many possible combinations are there? Two. It can take two values, either 0 or 1. So what will happen to output? Output will be complemented. So zero's complement is 1, 1's complement is 0. Okay. So this is called as a NOT gate. Apart from this, we also have a gate called as buffer. Its use we learn later on. So in this buffer, the symbol is similar to NOT gate. Okay. So what is the difference between this buffer input, buffer symbol and NOT gate symbol? What is the difference? Can you identify? Can you identify the difference between these two? What is the difference in the symbol? क्या difference है इन दोनों में? This one,
Sir, there is.
there is no circle, means there is no bubble after this triangle. There is no bubble after the triangle. So this bubble is there, it is a NOT gate. No bubble, it is a buffer. Okay. So buffer, what happens? Whatever input you will apply, you will get same in the output. You will get same thing in the output. So if input is x, output is also x. If x is 0, output will be 0. Input is 1, output will be 1. Okay. So this four gates clear? Any doubt in this four gates? Any doubt in this four gates? कुछ doubt है अभी? Any four? AND gate, OR gate, NOT gate, buffer.
No, sir.
No, sir.
Next is universal gate, which is NAND gate and NOR gate. So as this name suggests, NAND. So NAND is basically nothing but a combination of NOT and AND. So what happens after AND gate? If you connect a NOT gate, okay, this is called as a NAND gate. This is called as a NAND gate. So if AB is input, what will be the output after this AND gate? Here what I will get after AND? AND gate का output क्या होगा? What used to be present?
A plus
Not A plus A dot B. Now this A dot B is input to this NOT gate. NOT gate, what it does? It complements the input. So what happens to this? This becomes A dot B bar. Okay. So the symbol for NAND gate is this. AND gate. Then we'll use a bubble. A B, output will be A dot B whole bar. A dot B whole bar. Okay. Now, if I'll write its truth table, what will happen? Two inputs are A, B. Four possible combinations are there: 0, 0, 0, 1, 1, 0, 1, 1. What will be A dot B? A dot B क्या होगा? First 0, 0, 0, only last is 1. Then output is A dot B's complement, means this one's complement, triple 1, then 0. So what will be the definition of NAND gate? Definition of NAND gate. If any of the one input will be 0, then your output will be 1. So in NAND gate, remember this point, in NAND gate, if any of the one input is 0, then output is 1. If any of the one input is 0, then output is 1. If both the inputs are 1, then output will be 0. So similarly, 3 input NAND gates are also possible. So A, B, C. What will happen to this output then of NAND gate? This will be A dot B dot C whole bar. Okay. Truth table, I'm not going into that. You can do that. Okay. You know what will be A dot B dot C, then you can find out its complement. Similarly, its counterpart. What will be NOR gate? As its name suggests. What will be NOR? Like NAND is
not plus or.
not plus or, not plus or. So NOR is NOT gate plus OR gate. So we have a OR gate, two inputs A, B. What will be output of OR gate? A plus B. Then we'll use a NOT gate. What will happen? This will be A plus B whole bar. So NOR gate's symbol is this. Remember in digital, your bubble means always a NOT gate. Okay. So this is A, this is B, this is the symbol of NOR gate. So just after the OR gate, I'm using a bubble only, and output will be A plus B whole bar. What will be A plus B? Here, what can I write? A plus B, 0, 0, 0, 0, triple 1. Then its complement, 0's complement is 1. This is 0, this is 0, this is 0. So what was the definition? Definition of NOR gate. If any of the one input is equal to 1, then your output will be 0. And if both the inputs are 0, then only your output will be 1. Okay. So this two, again, it also has possibility that 3 input NOR gates are possible, 4 input NOR gates are possible. So suppose for 3 input NOR gates, we will have 3 inputs. 1, 2, 3. A, B, C. So this will be A plus B plus C whole complement. Okay. Similarly, 4 input NOR gate is also possible. In that case, it will be A plus B plus C plus D whole bar. Now, these gates are called as universal gate. So with the help of this NAND gate and NOR gate, we can construct all other basic gates. Okay. So now let us start with the simple one. Let us first try to implement a NOT gate with the help of NAND gate. So in NOT gate, how many inputs are there? In NOT gate, one input. If input is A, output should be A bar. Now in NAND gate, how many inputs are there? 2 inputs are there. In general, when we say NAND gate means two input NAND gate. So if input is XY, output will be X dot Y whole bar. Okay. So now I want to implement this A complement with the help of this NAND gate. So what I can do, I can do one thing. Okay. If I'll apply A here, what will happen to output? Output will be A dot A whole bar. So in the logical operation, if we'll go for AND gate of or logical AND of same input, what will happen? What will be A dot A? A dot A, what will happen?
Sir, A.
A dot A is A only, so this will become A complement. Okay, so what will happen? If I'll short both the inputs of NAND gate, it will behave as a NOT gate or inverter. If you'll short both the inputs and if you'll apply the input there, then the NAND gate will behave as a inverter. Next, let us try to implement a AND gate. What happens in AND gate? What is the output of AND gate? If input is AB, output is A dot B. Using NAND gate, we are able to get this one. Now suppose AB will apply here, I will get AB complement. Now, how can I get AB out of AB complement? What can I do? From AB complement, how can I get AB?
Sorted through a NAND gate.
Means point is that we should go for a NOT gate. Then it will be AB double complement. Double complements cancel each other, so this will become AB. This will become AB. But this NOT gate I have to implement with the help of NAND only. Then what to do? I need to short both the inputs. Okay. So this circuit will give you the AND gate operation. Okay. Next, let me try to implement OR gate. Let me try to implement a OR gate with the help of NAND. Now suppose in an OR gate, what happens to output? If AB is input, output is A plus B. Now in a NAND gate, I am getting this A, this is B. So I am getting here A dot B. One second, let me write in terms of XY. If this is X, this is Y, this will be X dot Y whole bar. Now let me do one thing. Suppose I will connect a NOT gate here, NOT gate here. Okay. I will apply A here, B here. Okay. So now, what will be the value of X here now?
A complement.
This will be A complement. Y will be
B complement.
B complement. So now, in place of X, what can I write? I can write A complement. In place of Y, I can write B complement. Then its whole complement. Do you remember De Morgan's theorem?
Yes.
What do you mean by De Morgan's theorem? A dot B whole complement is equal to A bar plus B bar. So same thing can be applied here. So now this will become A double complement plus B double complement. So A double complement is A, B double complement is B. So this is A plus B, which should be the output of the OR gate. So this is already NAND gate. So just we implement two or we use two NOT gates. So what we can do? We can implement that NOT gate with the help of NAND. So what we can do now? Simply NOT gate can be implemented by shorting both the inputs. By shorting both the inputs. So if you see in the next slide, same thing is mentioned. Okay. Same thing.
Yes.
So with the help of that, we'll be
Can you
able
show
to.
the last slide, sir?
This one only. Tell here only. This is the slide, na? Whatever I've done here, that is the circuits are here. Check it. Is it clear? These three?
Yes, sir.
Okay. So similarly, you try to implement the with the help of NOR gate, try to implement all other basic gates. Okay. Next. So I will share you this slide. Okay. So try to do other things also. Okay. Next. Next two gates are called as XOR gate and XNOR gate. Okay. So again, they are also very useful gate. So its name comes X or X NOR. Okay. So it has one particular application, because of that we are using it. So XOR gate, first of all, they are both XOR and XNOR. They are first of all two input gates. Okay. So three inputs are not possible here. That was the possibility in case of other gates like three input AND gate, three input NAND gate. So that thing is not possible in this XOR and XNOR. They are available only in two inputs. Next, its symbol. So for XOR, symbol looks like this. This is somehow similar to OR gate. Okay, this is X, this is Y. So how it differs from OR gate? Only this part is extra, nothing else. Okay, only this part. Observe this green color. Only this part is extra. Otherwise, it is OR gate symbol only. Okay, so this is denoted as X XOR Y. So XOR is plus inside a circle. XOR is a plus inside a circle. So if I write its expression, basically this X XOR Y is nothing but X bar dot Y plus X dot Y bar. X dot Y bar. So let us see what will happen to output. Now we have two inputs XY. So we have four possibilities: double zero, 01, 10, 11. Okay. Now if I'll find out X bar, what will be X bar? X bar क्या होना चाहिए?
1101.
1100. What should be Y bar?
101.
1010. Just we are taking the complement, nothing else. Next, to find X bar dot Y, what will be X bar dot Y? And of this two, 0.1 0, 1.1 1, 0.00 1.00. Similarly, next, X dot Y bar means this column and this column. So 0.1 0, 0.0 0, 1.1 1, 1.0 0. Then addition of this two column, X XOR Y. This is addition of this two. 0 plus 0 0, 1 plus 0 1, 0 plus 1 1, 0 plus 0 0. Okay, so what happens here? So can you now identify, one second. Okay. Now you check when your output is equal to 1 for this operation, these two combination. Okay. So in those two combination, what is the value of X and Y? Check the first combination, it is 0 1. Next combination, it is 1 0. So they are same or different in these two not same, no. Here it is 0, it is 1. Here it is 1, here it is 0. This one. Here it is, sorry. Here it is 0, here it is 1. Here it is 1, here it is 0. So in a combination, both the inputs are different. Okay. Now check where your output is 0, these two combination. Here both XY are same. So this XOR comments about the difference between the input. If both the inputs are different, then only your output will be 1. If both inputs are different, then only your output will be 1. Otherwise, your output will be 0. So they comment about dissimilarity. If both inputs are not same, then only your output will be 1. Okay. This is the importance of this XOR gate. It is commenting about the dissimilarity. Similarly, its counterpart is XNOR gate. XNOR gate symbol again same as XOR, just we need to add a bubble after that. Okay, so again, so this has to be X XOR Y's complement. So it is rendered with X XNOR. XOR is plus inside a circle, XNOR is dot inside a circle. Okay, so this is the complement of XOR. So what will happen? If we simplify this, we will get xy plus x bar y bar. Xy plus x bar y bar. So let us do it here only. Okay. So what will be x bar y bar? X bar y bar is this. 1.1 will be how much? 1.1
1,
1. Then 1.0
0,
0. Then 0.1 0. 0.0 0. Then x dot y, xy is this 0.0 0. 0.1 0. 1.0 0. 1.1 1. Then if we'll add this two, this will give us XNOR. So 1 plus 0 1. 0 plus 0 0. 0 plus 0 0. 0 plus 1 1. Okay. So now, what can you comment about this XNOR gate? Just check this particular combination and tell
the values are same and the
when
values of the x and y are same,
when
then it
both the
will be
inputs are same, then only your output is 1. When both the inputs are same, then only your output will be 1. Otherwise, your output will be 0. So it is talking about similarity. If both are same, then only your output is 1. So next, a simple question. So let us try to implement a NOT gate with the help of a XOR gate. We need to implement a NOT gate or inverter with the help of XOR gate. So XOR gates, how many inputs are there? Two inputs are there. X, Y. What will happen to output? Output will be x bar dot y plus x dot y bar. Okay. NOT gate, what we want? If input is A, output should be A bar. Remember, in digital, whenever you want to design something, okay, so that input will be available. If input is not available, how you will design? Okay, so you want to design this, that means A is available. So apart from this, always with you, logic 1 is available and logic 0 is available. So these things will always be available with you as a designer. Now, you know X or Y, you know what to get. Now tell me a solution. What can we do? Where we can apply A and what we should apply in both X and Y such that we'll get A bar. So this point is just we need to compare these two, nothing else. Compare and tell. If we compare what I should write in place of X, can I write in place of X A bar? Will it be okay if I'll write? No issues. If it will be a bar, what should be the value of y? Y क्या होना चाहिए? Y should be such value such that this will give me a bar.
Sir,
क्या
B.
होगा? B कैसे होगा? B होगा तो a bar डॉट b हो जाएगा ना. मुझे क्या चाहिए? a bar चाहिए. तो क्या लिख सकता हूँ वहां पे in place of y?
Sir,
A dot a bar क्या हो जाएगा? If we'll go for a bar, if a will be 0, a bar will be 1. What will happen to a dot a bar? 0. a अगर 1 होगा तो a bar 0 होगा, उसमें भी 0 हो जाएगा.
Sir, A bar.
a bar करेंगे तो फिर a bar ही होगा. a bar dot a bar will be a bar. 1 होना चाहिए ना. a bar dot 1 लॉजिकल एंड है ना. So a bar dot 1 is same as a bar. A bar dot 1 is same as a bar only. Okay, let us check. So you studied this thing in your plus 2 or you have not studied? Have you all studied this thing?
Sir, studied but not in depth.
Oh, yeah, no, this is basics only. Okay. So what happens? Now suppose one input is a bar, another input is 1. So this will be fixed only. Okay. So what will happen? A bar dot 1. What will happen? AND gate of 0 dot 1 is 0.
A.
1 dot 1 is 1. So this 2 is same as this 2. So a bar dot 1 is same as a bar only. A bar dot 1 is same as a bar. Okay. So this plus मैंने x की जगह पे a लिया है तो यहाँ पे क्या होगा? a आ गया. y की जगह पे क्या लिया है? 1 लिया है. 1's complement. What is 1's complement? 1's complement is 0. What will be a dot 0? It is an AND gate. If 0 is there, result will be always 0. So this will be a bar plus 0. What will be a bar plus 0? In addition, if you add something with 0, result will be a bar only. So by connecting a here and y is how much? Y should be 1. By connecting 1 to this XOR gate will behave as a inverter. This will behave as a inverter. Similarly, how it will behave as a buffer? Buffer means what? What we should get? We should get a in the output. अभी सेम टाइप ऑफ क्वेश्चन बताओ क्या करना चाहिए कि आउटपुट ए आएगा. क्या करना चाहिए? अगेन अगर मैं x की जगह पे a लूंगा तो ये a बार हो गया. a बार मुझे नहीं चाहिए तो y का वैल्यू क्या होना चाहिए?
sir, 1.
1 होगा तो a बार आ जाएगा ना. नहीं चाहिए. So if you multiply with something, with what you should multiply? You should multiply with 0.
0.
To multiply something with 0, it will give you the 0 plus. x की जगह पर a लिया है, y की जगह पे 0's complement. 0's complement is what? ये a bar dot 0 0 हो गया. a dot 0's complement is 1. So ये हो गया a plus 0 is a. So same circuit, if we just modify this y to be 0, it will behave as a inverter. Okay. So similarly, you try to do it for the XNOR gate. Check how XNOR gate can behave as a buffer and inverter. Again, same thing, just you need to exchange the values. Okay. Next important thing is 3 input XOR gate. So I told you in the beginning, all other gates multiple inputs are possible, but in case of XOR multiple inputs are not possible. There is no multiple inputs are possible. So XOR gates are available only in this format. Only 2 input XOR gates are only available. Okay. Now suppose I want to do A XOR B XOR C, then what to do? First of all, you need to find out A XOR B. Then you need to take another XOR gate. So here you will get A XOR B XOR C. In this way, you can find out. Okay. So in similar way, if I find out first A XOR B, what will happen? XOR में क्या होता है? If both inputs are different, then output will be 1. If both inputs are same, output will be 0. Both are same, 0. Both are same, 0. Both are different, 1. Different, 1. Different, 1. Both are different, 1. Both are same, 0. Both are same, 0. Now this we need to compare with this one. See, this and this. So what will happen? A XOR B XOR C. 0, 0. Both are same. So 0. 0, 1. 1. Both are different. 1, 0. Both are different. So 1. 1, 1. Both are same. So 0. 1, 0. Both are different. So 1. 1, 1. Both are same. So 0. 0, 0. Both are same. 0. 0, 1. Both are different. So 1. Okay. Now same thing is mentioned here. Now, but suppose we have 3 input XOR gate, so it is not always possible for us to do like this. So we'll need a shortcut by which we can directly tell about A XOR B XOR C. And this is the result. F is the result, which is A XOR B XOR C. So for this particular combinations, your output is 1. Okay. So in where I marked it with yellow color, you count the number of ones in a combination. How many ones are there in this first combination? कितना वन है? First one एक है यहाँ पे. Here second
One.
one. Here in third
One.
one. Here three. Check for the other combination where corresponding outputs were 0 and where yellow color is not marked. Here no one. Here 2. Here 2. Here also 2. So what you can comment? If odd number of ones are there, then your corresponding output will be 1. If odd number of outputs are there, then for A XOR B XOR C, your output will be equal to 1. ठीक है? ओके, ये नहीं हो पाएगा, इसको नेक्स्ट क्लास करते हैं बूलियन अलजेब्रा. ठीक है? So we'll do that in the next
Last
week.
slide, sir.
So I'm sharing the PPT, na? Why you are taking screenshots?
Okay, sir.
Sir, can you explain one more time 3 input XOR?
In the similar way, you will proceed A XOR B XOR C XOR D. What will happen? You need to take again. यहाँ पे हो गया XOR B XOR C. Another input you will take here D. This will be A XOR B XOR C XOR D. One thing to remember, okay. So this A XOR B is equal to A XOR B's complement. So this is valid if it is only 2 variables or 4 variables or 6 input variables. If it is an odd number, then this formula will not be valid. A XOR B XOR C will not be equal to A XOR B XOR C's complement. Okay. So you can try that. Okay. Just remember this for short questions. Okay. So everyone write your roll numbers in the chat box. Roll number in the full. Write your whole roll number. So those who have written roll number, they can leave.
Any combinational circuit, so gate are also the combinational circuit. So what is the truth table? That is the truth table is a table in which we have list all the possible combinations of input variables and the corresponding output, right? It's called the truth table. Please note it down. So what is the truth table? gate table